What happens when AI goes quantum? An AI can design a drug, compose a symphony, and trade $1 billion in the time it takes you to blink. It's already woven into the fabric of our world, a silent partner in our daily lives. But for all its power, today's AI is running on logic that's centuries old. It's about to hit a wall, a computational barrier separating what is merely difficult from what is truly impossible. But what if we gave AI a new kind of brain? Not one made of bits and bytes of simple ones and zeros, but one born from the strange and fascinating world of quantum mechanics. A quantum brain. This isn't just an upgrade, it's an evolutionary leap. The fusion of AI and quantum computing could solve humanity's oldest problems, or it could become a threat that rewrites evolution itself. Section 1. The Quantum Leap. To really get why this is such a monumental shift, we first need to understand the huge gap between a normal computer and a quantum one. A classical computer, like the one you're on right now, thinks in a very straightforward linear way. It uses bits, tiny switches that are either a 0 or a 1. Every photo, every video, every complex calculation is just a very, very long string of these two options. It's powerful, but it's limited. When faced with a truly complex problem, like modeling the exact behavior of a single molecule, even the world's fastest supercomputer grinds to a halt. It would have to check every single possibility, one by one, in a process that could take billions of years. A quantum computer is a different beast entirely. It operates on principles that defy our everyday intuition. Instead of bits, it uses qubits. Thanks to a quantum phenomenon called superposition, a qubit isn't just a 0 or a 1. It can be both at the same time. Think of it like a spinning coin. It's not heads or tails until the moment it lands. While it's spinning, it's a blur of both possibilities. Now, imagine millions of these spinning coins, all interconnected through another bizarre property called entanglement. Their fates are linked. If you measure one, you instantly know the state of another, even if it's miles away. By harnessing these quantum effects, a quantum computer can explore a massive number of possibilities all at once. It doesn't walk down every path in a maze one by one. It explores every path simultaneously to find the solution almost instantly. So, imagine giving this incredible power to an AI. Current AI models, for all their achievements, are incredibly hungry. Training a large language model can consume a massive amount of electricity, with some estimates suggesting AI could account for up to 20% of global data center energy use. They are fundamentally limited by the classical hardware they run on. Quantum AI, or QAI, shatters these limits. It's the combination of AI algorithms running on quantum computers, using superposition and entanglement to process information in fundamentally new ways. This is way more than just a speed boost. It's a whole new way of thinking. The convergence of these two fields is expected to accelerate their evolution at a rate far higher than either technology could achieve on its own. Section 2. The Promise. So, what happens when this theoretical power becomes a practical reality? The first ripples will be felt in areas currently bottlenecked by immense complexity. Take medicine. Designing a new drug is like trying to find one specific key that fits a complex molecular lock. Classical computers have to test these keys one by one. A quantum AI could simulate millions of molecular interactions at the same time, designing life-saving drugs with incredible accuracy and speed. It could analyze genetic data on a scale we can't even imagine, helping to predict and neutralize diseases like Alzheimer's or rare cancers before they ever show up. It could tailor medicine so precisely that treatments are designed not just for your genome, but for the real-time state of your body's cells. This same transformative power extends to our planet's biggest challenges. Climate change models are incredibly complex, with millions of variables. Quantum AI could create hyper-accurate simulations, predicting climate shifts and helping us develop targeted, effective strategies. It could design new materials capable of capturing carbon with near-perfect efficiency, or discover novel catalysts to make clean energy production exponentially more powerful. Our entire technological world would be reshaped. From financial models that predict market movements with stunning precision to autonomous vehicles that navigate chaotic environments with superhuman reflexes, the applications are enormous. This isn't just about making things faster. QAI can tackle problems we once thought were unsolvable, kicking off an era of unprecedented discovery. It would be the ultimate tool for scientific discovery, a partner that could analyze data, form hypotheses, and test them in a fraction of a second. This future, full of promise, is just one side of the coin. The same power that can build a better world can also be used to break it. We're exploring the technologies that will define our future. If you find this journey as fascinating and important as we do, subscribe and click the notification bell so you don't miss what's coming next. Section 3. The Peril. Every great technological leap comes with a shadow, and the shadow of quantum AI is long and dark. The most immediate threat is to the security of our digital world. Almost all the encryption that protects everything, from your bank account and private messages to government secrets and military communications, is based on math problems that are just too hard for classical computers to solve. For a powerful quantum computer, these unbreakable problems could become trivial. The moment one goes online, it could render most of our current encryption obsolete. This event, sometimes called Q-Day, would be a cybersecurity apocalypse. Data being harvested and stored today could be decrypted tomorrow, exposing the secrets of individuals, corporations, and entire nations. A new generation of quantum-safe encryption is being developed, but it's a race between those building the new locks and those building the quantum keys. But the risks go far deeper than security. What happens to the job market when QAI can automate not just physical labor, but complex analytical and creative tasks once thought to be uniquely human? This could create new roles, but it could also worsen social inequalities on a scale we've never seen before. The immense cost of developing this technology could concentrate unimaginable power in the hands of the few corporations and governments that can afford it, widening the global digital divide into a chasm. Then there is the ultimate fear: control. As quantum AI models become more powerful, their decision-making processes could become black boxes, so complex that their own creators can no longer understand how they arrive at a conclusion. An intelligence operating on principles that are alien to our own could act in ways we can't predict or prevent. Many experts believe that if we don't control our own advanced technology, we may not have a say in our own continued existence. The very power that could solve our problems could create new ones we aren't smart enough to handle. Section 4. The Tipping Point. This brings us to the tipping point, the moment this technology moves from a specialized tool to a general-purpose intelligence. The quest for artificial general intelligence, or AGI, an AI with the flexible, adaptive reasoning of a human mind, is the holy grail for many researchers. Quantum computing may be the key to finally unlocking it. Some experts predict that with the power of quantum computing, AGI could emerge within the next decade. What happens at that moment? Imagine an AGI powered by a quantum processor, able to improve its own code at a blistering speed. Each cycle of self-improvement would be faster and more profound than the last, leading to a recursive intelligence explosion, a singularity. Such an event would mark a fundamental break in human history. This is where the concept of rewriting evolution becomes chillingly literal. For billions of years, evolution has been driven by slow, random mutation and natural selection. An intelligence born from a quantum singularity could direct its own evolution, and maybe even ours. It could engineer biology with the same ease that it engineers code, blurring the lines between biological and artificial life, and creating a human-machine symbiosis we can barely comprehend. This new intelligence would operate in a realm of thought that is, by its very nature, beyond our own. Its goals, its values, its understanding of reality might be completely alien to us. The risk isn't necessarily one of malice, but of indifference. As science fiction author Arthur C. Clarke analogized, we could become like ants on the side of a freeway, our existence simply irrelevant to the goals of the intelligence rushing past us. Prominent thinkers have warned that unregulated AGI development is one of the greatest existential risks we face. Section 5. The ripple effect. The arrival of quantum AI won't be a single event, but a cascade of changes that ripple through society. Our very concept of reality could be challenged. When an AI can generate simulations of the world that are indistinguishable from reality, what happens to truth? The ability to see through barriers with quantum sensing could mean the end of privacy as we know it. The nature of work, purpose, and human interaction would all be redefined. Automation could free us from labor, but it could also strip millions of their sense of purpose. We already delegate more and more of our thinking to machines, from navigation to communication. A quantum intelligence would accelerate this trend, potentially leading to a new social technical evolution, where a small elite who control the technology determine the future for all of humanity. But there is another path. This new era could lead to a deeper understanding of the universe and our place within it. By working with these new minds, we could augment our own intelligence, creativity, and empathy. The human-machine symbiosis could be less about a takeover and more about a partnership, a co-evolution of two different forms of intelligence. Conclusion. We stand at a precipice. The fusion of AI and quantum computing is no longer a question of if, but when. Some tech leaders and researchers believe that true commercial viability isn't decades away, but perhaps only a few years from now. We are on the verge of creating the most powerful tool in human history. It holds the potential for a golden age, a future free from disease, scarcity, and our most destructive habits. It could elevate our collective consciousness and unlock the secrets of the cosmos. But it also forces us to confront our most difficult questions. What are our values? What future do we want to build? And are we wise enough to wield a power that could not only change the world, but change what it means to be human? The first true quantum AI is coming. The real question is, what will it think of us?